Cole, do you want to hit the light? One of the light switches for us? The one closest to the doorknob. That's the one. Quick little review from last time, since we've had a whole entire weekend. This was not part of the quiz, but it may be asked as part of the exam if a function is one-to-one. Okay. How do you see if something's a function? You do what kind of a test? Vertical line test to test if it's a function. There's a similar function for one-to-one. It was the horizontal line test. So for example, this one in black, if you look at your notes, this one's not one-to-one because it does not pass the horizontal line test. What's the significance of it not being one-to-one?
The inverse is not a function.
Yeah, it still has an inverse. This one in red is the inverse, but it's not a function. Okay? This graph in black is one-to-one because it passes the horizontal line test. And if you consider its inverse graph right here, the one in red, that is also a function. That's the importance of a function being one-to-one. Okay? All we had time for last time was this problem here. You should have example 1 part A already. You guys have this problem? We need to add on to this. There was something really important that we didn't have time for. A lot of students have trouble either listening to this or understanding it, but it has to do with the domain and range of a function compared to the domain and range of the inverse of that function. So this is the function we started with in example 1a, yes?
Yes.
Let's talk about the domain of this, of the original function. This is really important that you pay attention to this. What's the domain of the original function we started with in example 1? -2, comma, infinity. What about the range? Now, the range is a little bit harder to find using an equation. Yeah, you're right. If you were to consider the graph of this, though, a real quick sketch of this graph, doesn't the +2 move it to the left 7 or to the left 2 units? What does the -7 do to the graph? Moves it down 7. And a square root graph kind of looks like that. So considering a quick sketch of the graph, what's the range from -7? Now consider the equation that we ended with. This is the inverse. Okay. Now, if I had given you this one in black to begin with, and we didn't consider this the inverse of that one there, what would you say the graph of a quadratic is? All real numbers. Do you guys agree? But this is not a normal quadratic function. This is the inverse of a radical function, of a square root function. So this domain is not all real numbers. How do you find the inverse of a function? You switch the place of x and y. You listening carefully? Well, what's represented by domain? What variable represents domain? X. What variable represents range? The y. If we switch the place of x and y to find the inverse, guess what we have to do with domain and range? These are just x's and y values, right? Domain and range. So if we switch the place of x and y, listen carefully to how I'm going to state this. The domain of the original function becomes the range of the inverse function. The range of the original function becomes what? The domain of the inverse function. Why is that? You switch the place of x and y. Okay? And if you're not listening carefully, if I were to ask you to find the inverse of that function, you could all do it. But quite often, students struggle with the question, all right, what's the domain of this? Because all they see is that this is a quadratic function. Yes, it's a quadratic function, but its domain is the range of the function you started with, which is restricted here. So the domain is restricted there. So how do we state the domain for this one? What's the domain? The domain is from -7 to infinity. And what's the range? -2 to infinity. Okay. Example 2. F of x, sorry I'm going real quick here, f of x equals x plus 4 squared minus 5. Part A of this question is f of x 1, 2, 1. We didn't talk a lot about how to find one-to-one in the equation of a function. So consider the graph of that equation. What kind of graph is it? It's quadratic. It's a parabola. Would it pass a horizontal line test? No. So is this function one-to-one? No. It's not one-to-one because the graph of it is a parabola. Now, part B is going to be an interesting question. I want you to restrict the domain of f of x so it is one-to-one. This function is not one-to-one on its entire domain, negative infinity to infinity. But if we can restrict the domain of this parabola in such a way that it becomes one-to-one, then I'm going to ask you to find the inverse. Why would I want you to make it one-to-one before you found an inverse? So the inverse could be a function, exactly. Because I know you all know how to find the inverse of this. That's not the point. Finding the inverse of the function is easy. You need to find the inverse in such a way that it is a function. Okay? Now, let's consider a quick sketch of this graph, this parabola. What does the plus 4 inside do to the graph? Moves it to the left. The minus 5 moves it down 5. So there's the vertex of the parabola. So just a quick sketch of that graph looks something like that. What if we were only to consider the right half of the parabola? If the black half of that were gone, wouldn't the right half represent a function that is one-to-one? So how do we restrict the domain to include only the right half of that parabola? Which x value would I want to start with to only graph the right half? Say that again? Negative 4. If we restricted the domain from negative 4 to infinity, wouldn't we have to get rid of the whole left half of that parabola? You guys follow me here? Now, couldn't we have started maybe negative 6 or negative 7? Why did it have to be at negative 4? That's the vertex. Okay? Now, we could have, I guess, done the left half, but traditionally, for a problem like this, you want to take the right out. I'll explain why in a second. But if we restrict the domain from negative 4 to infinity, now is this one-to-one? Is this function one-to-one? Yes. This function is now one-to-one. We've restricted the domain from negative 4 to infinity. So part C, let's find the inverse. What is the inverse of f? What's the inverse of f? Switch x and y. So we're going to have x equals parenthesis y plus 4 squared minus 5 Now we add 5 and add 5, so we have x plus 5 equals quantity y plus 4 squared. Now what? Now we square root both sides. So the square root of x plus 5 and we subtract 4, so we have square root of x plus 5 minus 4 is on the outside of the square root, and that's equal to f inverse of x. Yeah, because technically we started in function notation here. Where was it? We started using function notation, so you should end in using function notation. What's the domain? The domain is from -5 to infinity. The range is -4 to infinity. Now let's just double check that this matches what we began with. We restricted the domain in part B, so this is the domain of the original f of x function. What was the range of the original f of x function? -5 to infinity. So comparing the domain and range of the original function to the domain and range of the inverse. Did we switch the place of x and y? Did the domain become the range and the range become the domain? Okay. Well, that's about it.